Hey, pre-calc students. I would like to just show you really quickly how to do some of the function operations in Desmos. So we're adding and subtracting and multiplying and dividing and composing functions. So instead of typing in a function like y equals 3x plus 2, you're going to need to use function notation like f of x. And then the next function, you don't call f of x, you call it maybe g of x. So let's say you're going to do g of x equals x squared. So it would make two graphs. And then you could add f of x plus g of x on the next line. You could subtract, or let's say you multiply them. Makes a new function, see? So the benefit of this is that you see the actual domain and range of these things. You can kind of compare them to the original. Let's use something that has like a domain restriction, like the square root of x plus 1. Okay, so x squared is just a parabola, and the square root of x plus 1 is a square root function. So if you add them, you get something like this, and you can see that its domain is everything 1 and greater. It starts at 1 and then does a little loop and it goes back up. And so that domain is restricted by f of x. You can see they have the same domain, but it doesn't have the same domain as x squared, which is all the numbers. So that's how I want you to do the worksheet or the notes. So the notes page is this one. And so what you're going to do, you can see the different notations for adding and subtracting and multiplying and dividing. And so I give you a couple of functions, and I want you to use it. So first I want you to just add them up. If you can simplify them, simplify them. And then I want you to use a grapher, such as Desmos, and do it the way that I just showed you, okay? So you're going to do that for all four. So just when you do the domain, remember, you can't have negatives under square roots. You can't have 0 in the denominator. Those are the main two things that I'm using here. Okay. All right. And for implicitly defined functions, you need to rewrite a relation that is not a function as two implicitly defined functions you want to solve for y. And to solve for y, you just want to get y alone. If you need to see examples of this, look at your book. Okay. All right, so that's what I want you to do for the notes. And then there's another page that is a practice page that you can do on your own. Okay? All right, that is all that I wanted to say.